So we're going to go through the example 10 from 4.16. The Leon Burnit Advertising Agency is trying to determine a TV advertising schedule for the Chrysler Auto Company. They have three goals. The ad should be seen by at least 40 million high-income men, 60 million low-income people, and 35 million high-income women. There are two types of ads, those shown during football games and those shown during soap operas. At most, 600 can be spent on ads, and the advertising costs and audiences are shown in the table below. They must determine how many football ads and how many soap opera ads to purchase for Chrysler. So first we need to determine our decision variables. So let's make x1 be the number of minutes of ads shown during football games, and we'll have x2 be the number of minutes of ads during soap operas. From here, we want to think, are we minimizing or maximizing? And if our goal is to maximize or minimize their sales, so they want to spend the least amount of money with maximizing their viewers. So we want to next look at our constraints, because we're going to think about if we're exceeding our goal or if we're going to underachieve our goal. So I want to make it be called SI positive and SI negative. Our positive is if we're achieving our goal. Our negative is if we're underachieving that goal. So SI positive is the amount by which we exceed our goal. And this is either goal 1, 2, 3, or 4. So a minus is the amount we are under our goal. Our I goal. And our I in this case is goal 1, 2, or 3. Our next thing we want to look at are the constraints. So we have our constraints based on our goals. It tells us our first goal constraint number 1 will be based on our first goal. If we go back up to our goals, we want at least 40 high-income men. I'm going to copy this. 40 high-income men to see our ad. So if we look at our constraint 1, we need high-income men, which are 7 from football, 3 from soap opera. So we have 7x1 plus 3x2. But then we also want to see what we overachieve and what we underachieve. So we're going to add our S1 minus and then subtract our S1 plus, and it has to be 40 high income men. We want to look at our goal 2. Our goal 2 is looking at the 60 million low-income people. Our low-income people are 10 from football, plus 5 from soap opera. Then we need to add our It won't let me draw my S. And we need that to be 60. Our third goal is our goal that looks at high-income women. Our high-income women is 5 from football and 4 from soap opera. Then let's look at underachieving, goal 3, and overachieving, goal 3. And we said we need 35 high-income women in millions. Our last constraint we can look at is the budget constraint. So we know we have $600,000 to spend, and in that table it gives us the price of football. It also gives us the price of soap operas, and it has to be less than or equal to our 600,000. And since if you do them all proportionate, you don't have to write the thousands. The next thing we want to look at is our non-negative constraint. We can't show any negative ads. So all the variables need to be non-negative. And this would be x1, x2, si minus, si plus, all have to be greater than or equal to 0 because they're all non-negative. Our last thing we want to look at now is our cost function. So looking at our cost function, we're trying to minimize u So we have our final summary, and if we want to look at it, we can pull this on the next slide on the summary tab.
By graphing the constraints, you'll test the feasibility of the objective. The high-income male constraint, 7x1 plus 3x2 is greater than or equal to 40, is graphed here shown in red. The low-income person constraint, 10x1 plus 5x2 is greater than or equal to 60, is shown here in blue. The high-income woman constraint, 5x1 plus 4x2 is greater than or equal to 35, is shown here in green. And the budget constraint, 100x1 plus 60x2 is less than or equal to 600, is shown here in purple. By graphing the equations of each of the lines and their respective regions, you can see by where the regions overlap that there is no feasible solution for all of the viewership constraints that meets the required budget constraint. The problem continues stating that Burnit asks for Chrysler to identify a failure cost related to each viewership constraint. Chrysler determines that for each million exposures by which Chrysler falls short of the HIM goal costs Chrysler a $200,000 penalty due to lost sales. Similarly, for each million exposures by which Chrysler falls short of the LIP and HIW goal costs Chrysler $100,000 and $50,000 respectively.
Hello, my name is Ivan. So right now I will be doing the last part. It is checking all the goals and checking all the constraint, and I will solve the deviation also. So from the first two part, we get the objective function it is to minimize the all goals exact. So we have to minimize the all goals. So it is a minimization function, minimize z, which is equal to 200 s 1 negative, and then plus 100 s. Let me copy this and is 2 and negative plus 50 is 3 negative. It is 100. Okay. Now this is also a negative function. So because this is underachieved value. So now and subject to, and the constants were 7 into x 1, okay, perfect, and then plus 3x 2 plus let me write this one, let me copy this one here, plus s1 negative, and which I have to minus s1 positive. Well, okay, which is equal to 40. So this is the first constraint. Uh, Let me write the side note. It is high income man. Okay, let's copy this one and write the second constraint and the third constraint. Let me correct them. It is 10, and the last one is gonna be 5, and which is in the budget constraint x. Copy this one. Perfect. It is okay. What is this one? This is 5, and this is gonna be 2. Okay, this side is gonna be 60. This side is 35. It is 4, 3. Okay, 6, which is equal to 60. So the second constraint is low income people, and it is high income women. Man, this is and this constraint is the budget constraint. Perfect. Which is obvious in millions in which we which uh, constraint divide by 10,000 by 10,000. Okay, just let me put this one. Perfect. Okay, from the last section, we after the graphical solution, we get feasible optimal solution x. Let me copy this one. X1 which is equal to 6 and x2 is gonna be 0. So now we check those, we will put these values of x1 and x2 into the constraint. So putting these values to the constraints, and we get like 7 into 6. The first, okay, let me write it like this. First constraint 7 into 6 plus 3 into 0. Okay. Okay, which is equal to 42. However, the target was 40, so it is overachieved overachieved by 2 million. So the S as it is. So as it is overachieved, then S1 values is equal to 2 and S1 negative this is equal to 0. Perfect. And then LIP. Let's write that 10 into 6 plus 5 into 0, which is equal to 60, is it is the exact value of our target. So S1 is gonna be 0 and S2 value is equal to 0. The HIW, the third constraint will be right. So we are checking the values in every constraint. So in the third constraint, we can see that it is 5 into 6 plus 4 into 0, which is equal to 30. And however, the target was 35, so it is underachieved. So it's a pretty, we can say that it's not optimal, but we can write the values of the deviations as 3 is equal to, as it is underachieved, so the value of S3 is 5 and S3 is gonna be 0. Okay. Now, if you want to see the budget constraints, which is 10 into 6 plus 6 into 0 is equal to 60, the exact value, exact of our budget. So it pretty satisfies our budget. Now the budget so it was in now if we want to find the objective value, means z is equal to 200 into 0 plus 100 into 0 plus 50 into 5, which is equal to 250. So we get the objective value, which where the deviation is 3 minus is 5, as it is underachieved. So 5 million of, so we can write it from here, 5 million of, you know, 5 million. Okay, so 5 millions of third constant age high income women is missing. So hence we can say that the goal one and goal two was satisfied, but the least important goal, number 3, is not met properly. So the best we can do is to buy, 6 football ads and 0 soap ads to minimize our cost. So that's it. That's the problem where let's give it a let's give it a name of this bird, like check all the goals and compute the deviations. Uh, okay, compute. I don't know what is going wrong, but I think that's fine. So first, we write the whole summary, which we have to check. So the objective function and the constant, there are four constants. We have to see if all the constants are satisfied or not. From the last section, we got some feasible optimal solution of x1 and x2 by doing the graphical solution, of course, which is x1 equal to 6 and the other x2 is equal to 0. So then we checked all the constants by putting the values of x1 and x2 in those constraint, and we get the deviations value from there. And after finding the deviations, we put the deviations value on the objective value of ours, which is to minimize all the goals. You can see in our minimization function, 5 million of high income women is missing. So we have to say that the best we can do is to buy six footballers and zero soapets to minimize the cost, where we can satisfy the goal one and goal two, leaving the least important goal three. That's it. That's it from my side. Thank you.